Alright, ladies and gentlemen, we are going to be dealing with graphing exponential functions and also using their transformations. Now, what is an exponential function? Well, exponential function here uses a base, okay? And so we take the function of a base to some exponent. Now, as long as that base is greater than 1, okay, like a base 2 or a base 3, something like that, your graph is going to get bigger, and as the x value is on the positive side, it's going to exponentially grow. Okay, that y value is going to get bigger and bigger and bigger. As your x value is negative, though, notice it gets closer and closer to our x-axis, in which we're going to have a horizontal asymptote right there. Okay. Now, if that base, this value here, is a number between 0 and 1, okay, and just FYI, the base cannot be 0 or negative. Okay, we can only have positives, but notice if I have this number between 1 and 0, which is a fraction, a regular old proper fraction, notice the graph goes differently. Okay, so instead of this being increasing, you're going to have one that is decreasing. Okay, and the reason it's decreasing is we always read left to right, and notice it's getting lower and lower and lower, getting closer and closer to that x-axis, which is where that horizontal asymptote is. Now notice there is no vertical asymptote in these exponential functions. There is just a horizontal asymptote, and those are going to move when we have some reflections. And if you think about how things are going to transform, okay, we're going to have vertical stretch and shrink. We're going to have horizontal stretch and shrink, or compression, sorry. College algebra likes to use the word shrink. And then that's our left-right move and our up and down move. And we can also have our reflections over the x-axis on A and over the y-axis on B. Okay? So we're going to move things. Well, what's going to move the horizontal asymptote? Only an up and down move. So if I have a d value, our horizontal asymptote is going to move. Otherwise, it will not move. So let's talk about base 2 and how we would graph it. Here's an example of base 2. Okay? Notice if I plug in values for x, okay, like -1, 2 to the -1, if you remember your exponent rules, is 1/2. Plug in a 0. 2 to the 0 power is 1. Anything to the 0 power is 1. Okay, plug a 1 in, 2 to the first, that's 2, and then 2 squared is 4. So these are your parent points for base 2. Okay, now remember, as our x values get bigger, it goes forever up. As the x values get lower, you're going to have forever to the right, okay, and forever to the left and right, and you're going to have your horizontal asymptote right here at 0. Okay, so notice some of the things we see. Domain, all real numbers, left and right forever. Range from 0 to infinity, but notice we do not include 0. There is no x-intercept because of the horizontal asymptote, which is at y is equal to 0, and notice it is increasing. Okay, so that's how base 2 is always going to look. Okay, notice the 0, 1, okay, the 1, 2, and so forth. That's why it graphs like it does. So what happens when I have a transformation? Well, if I have a number out in front, that transformation is going to be a reflection over the x-axis. Now, here are my parent points again. Okay, you can stop the video real quick if you want to copy them down. Okay, reflection over the x-axis affects the y, correct? So it's going to make all our y values negative. So negative, 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 negative. Okay, so that makes everything from the top move down to the bottom. So notice these should all flip over the x-axis. Okay, so notice our points. -1 would be at -1/2. 0, negative 1, 1, negative 2, 2, negative 4. Make sure I get it in here. And notice we're going to have this. It's going to look something like this. Well, where's my horizontal asymptote at? Sorry. Where's my horizontal asymptote? Well, did I make a move up and down? No. So my horizontal asymptote is still going to be here. So what things can I tell from here? Well, horizontal asymptote is still at y is equal 0. Okay. Is this increasing or decreasing now? Well, left to right, it is decreasing. Okay, domain is still all real numbers. Range, well, forever down, all the way up to 0, not included. Still no x-intercept. And a y-intercept is going to be at 0, negative 1. Done. Okay, so let's look now at, let me try and get a little bit more, I don't know why it's so dark all of a sudden. There we go. Let's get you a little bit better view here. Alright, so we need to finish this one up here pretty quick. Okay, here's my points, here's my transformations. Base 2 transformations, I'm going to have a vertical stretch of 3 and a down 3. So vertical stretch of 3 means all these get multiplied by 3. 3 halves, 3, 6, and 12. And then down 3. So that's going to be down 3, which would be negative 1 half, 0, 3, and then 9. Okay? So what happens when I graph these? Okay? Remember, it should have stretched it and bring everything down. So this is negative 1 and 1 half, sorry, that's what I said. Okay? So negative 1 and 1 half would be about here. 0, 0, 1, 3, 2, 9. So we're going to have something that looks like this. Well, where is that horizontal asymptote? Well, remember, the only thing that moves a horizontal is up and down moves. Where I had an up and down move of 3, so that horizontal asymptote is going to be here. Okay? So, domain, notice, is always all the numbers for these. Range, asymptote up. So, negative 3 to infinity, not including negative 3. X-intercept. Well, there's an x-intercept, 0, 0. Y-intercept, 0, 0. Horizontal asymptote, we said, is y is equal to negative 3. Okay? And is it increasing or decreasing left or right? It is increasing. So, sorry, it went about a minute long on that video, but I think we got it all in.